Hey everybody, welcome to another DevFest event. Today we have a super interesting event because this is not your typical agents event like all the one before. It's actually something totally different, so I'm super excited for that. I don't want to take so much time from Nir. He will present the event, everything that goes inside, what is OpenTelemetry in general. So it's going to be super exciting. I'm going to give you here the giveaway, and I will prompt it a few more times during the event. So let me share with you all the link. Feel free to go in, put your GitHub handle, and by the end of the event, we will have 2 giveaways. So you will have to stay until the end of the event and watch everything, ask questions. It will be super fun. Except for that, please make sure, and I'll prompt it a few times during the event, that you go to OpenTelemetry GitHub repository and star it. So here is the link in the chat. And without any further ado, Nir, the stage is yours.
Hey everyone, can you hear me? I hope that my microphone is working. Okay, this is what I wanted to make sure. Cool. So, hey everyone, and welcome to getting started with OpenTelemetry for LLM observability. So we're going to talk a bit about what is OpenTelemetry first. Then we're going to talk about our open source OpenLLMetry that you already saw in the link in the messages, and we're going to show you a couple of examples of how you can use Open LLMetry to get observability to your LLM applications. And we're going to also talk about what is observability exactly. So a lot of things to cover. Feel free to stop me if you have any questions. You want to comment, and if something is not clear, I'm going to start right at the beginning, at the very basics of Open Telemetry and Open LLMetry. Cool. So let's get started. 1 second. Great. Okay. So for today's agenda, I'm going to talk a bit about OpenTelemetry and OpenLLMetry, and we're going to show you a quick live demo. And if we'll have some time, we're also going to talk about the monitoring in production. And if not, this will be our next talk on Wednesday. So before beginning to talk about OpenTelemetry and our open source, we need to talk about the origins and like the project that preceded it all, which is called OpenTelemetry. So OpenTelemetry is actually one of the largest projects maintained today by the CNCF. CNCF is the Cloud Native Foundation. They are part of the Linux Foundation, and they maintain many of the biggest open source projects and you probably heard about, like Kubernetes and many others. And OpenTelemetry began as a way to standardize the protocol that production applications are using to get observability to their application. So you have an application running in production, and you want to see the logs, you want to see metrics, you want to see if there are any issues with the application in production. And so for that, you need some mechanism to collect data from that application and sending this out to your favorite platform. So when everything when the cloud native environments began, every company like Datadog, Splunk, New Relic, they all built their own proprietary way of doing this observability. And then slowly came OpenTelemetry with a goal of standardizing this way of observing production applications. And the idea is that if you use OpenTelemetry in your application, so if you and we're going to talk a bit more about what exactly does it mean, but if you are observing your application with OpenTelemetry, then you can easily connect it to any of these platforms, and you can easily switch between them. So let's say I'm investing a lot of time, I'm integrating OpenTelemetry into my application, and I'm connecting into Datadog. but Datadog costs me too much money, or I'm not happy with it. I can easily switch to New Relic. It's just a matter of a simple configuration. And that began at 2019, 2018, I think even. And it slowly grew. Now it's the biggest, one of the biggest projects in CNCF after Kubernetes. It's supported by 30, 40 plus observability platforms, like all the major ones you can see here. And it's still actively maintained by the CNCF. So even if you want, if you love open source like me, if you want to contribute to them, you're welcome to look for the OpenTelemetry project and see for contribution options. And I think one thing I haven't, emphasized enough or explained a bit is what exactly do I mean when I say observability. So within the OpenTelemetry universe, when we say observability, we mainly talk about three different things: logging, metrics, and tracing. Logging is something you probably all have already used. Whenever you write, console.log in your JavaScript program, or print in your Python program or any other language, you're basically printing something to your, local console. But when you're deploying your application, those same prints just go out as logs. And then there are many different systems that know how to scrape these logs and send them out to whatever platform you're using for observability. OpenTelemetry standardized this mechanism. So if you log data with OpenTelemetry, you can send it out to any of the platforms that I mentioned. Oops. Metrics is the second type of observability you can have on your application. When we talk about metrics, we usually talk about things that we look at on aggregate. In the LLM world, we usually look at token usage, latencies, error rate, etc., etc. But if you just look at cloud observability, and this is where OpenTelemetry exists, we are thinking, you were talking about how much CPU is my database using, what's the latency of my HTTP call, how much memory is my process taking. So these are the sort of metrics that we can send out in a standard format using OpenTelemetry. And when you think about metrics, if you thought about logs, most of the time it's just textual data. Sometimes it's JSON, but usually it's text. Metrics is usually numbers, and the way we consume it is usually by looking at different graphs that show us how those metrics behave with time. Lastly, we have traces, and traces are actually where OpenTelemetry began. So when OpenTelemetry began, the only thing that was available was tracing. It was actually called Open Tracing. And I think it's one of the coolest part of OpenTelemetry, but also the part that's the most difficult one to understand. So what is tracing? Many times when we are running applications in production, especially when we're running in multi microservices, complex environments, each process happening internally, let's say I'm using Amazon, I'm buying something on Amazon, I have multi-step process that is happening behind the scenes to actually do that purchase that you've just made on Amazon. This process, which can span across multiple services and can have a lot of steps in between, a lot of writes into a database, etc., is most easily debugged and viewed using traces. So trace is kind of like a complex logging mechanism. It's a way for me to view a multi-step process easily. And taking it back to our domain, to generative AI, usually when we have a lot of multi-step processes. Let's say we have a RAG pipeline. So a RAG pipeline is a process where I'm going to a vector database, extracting some context, then sending this context together with a question I have gotten from the user to an LLM, and then I get the answer. So I had two steps process here. I first went to a vector database, got some information, and then I sent a request to an LLM to get the proper answer based on that context. So this multi-step process is something you can easily track when you look at the trace. As you can see here, you see how much time the whole process took, and you can actually trace different parts of that overall process. So this is OpenTelemetry, logging, metrics, and tracing. These are all standardized with OpenTelemetry. And if you're using OpenTelemetry as your go-to protocol for observability, you can basically connect it to any platform that you want. So it's a pretty cool project. So far I've described, the project as like some amorphic things, but we can also talk about, what is the code that is written under the OpenTelemetry umbrella. And so the OpenTelemetry is a huge ecosystem. It has almost 100 different open source projects under the OpenTelemetry umbrella. And the main things we can find there are SDKs, instrumentations, and a collector. We're going to go over them now. SDKs are the way for us to use to actually produce the OpenTelemetry protocol in our application. So when I'm saying I want to observe my application with OpenTelemetry, I'm actually saying I'm installing the OpenTelemetry SDK into my application. So let's say I have an app in Python, I can install the OpenTelemetry Python SDK, and then I'm using OpenTelemetry. I can start sending the data that I'm automatically producing. I can send it out to Datadog, Dynatrace, New Relic, whatever you want, pretty easily. Right now, OpenTelemetry supports 11 different languages. So any major programming language that you are using today is probably supported by the OpenTelemetry SDK. The second thing we have in OpenTelemetry is what is being called instrumentations. So when I talked about the SDK, I was actually lying. If you just install the SDK, nothing will happen, because if you're using the SDK, you need to actually, if you want to send a log, you need to actually write, some method that actually calls the OpenTelemetry API and sends a log message. And if you want to create a new metric, you actually need to write some code that creates this metric and send it out in the standard protocol. But OpenTelemetry makes our lives much easier. They've built something which is called an instrumentation, which automatically produces some of these traces, logs, and metrics for some, many of the well-known technologies that we are using. So let's say you're using MySQL or Postgres. You can install the OpenTelemetry Postgres instrumentation, and you automatically get a lot of information into your how you're making calls to your database. So it's pretty cool. You install the SDK, you install the Postgres instrumentations, and boom, you have some metrics about how your database is being used, how efficient is your calls to the database, just by installing two different packages. There are tens of different instrumentations in OpenTelemetry for databases, from frameworks, for everything that you want. The last thing we have in OpenTelemetry is called a collector. A collector is, it's always like the third thing I have here is the most complex part. So again, the collector is the most difficult part to understand when we talk about the ecosystem. But when we think about the deployment of our application, we have an application running, let's say in Python, and it's sending out some data using the SDK and the instrumentations in the standard OpenTelemetry format. So it's sending logs and traces and metrics. So this data can be directly sent to one of the observability platforms like Datadog, but we can also put something in between. That something is called the collector. And the main reason we want to put it there is because we want to do some extra processing before we send the data out. What are the things we can do before we send observability data out of our system? We can reduce the volume. One of the main things, if you talk about huge companies, the volume of data that is being sent for observability purposes, the amount of logs, the amount of metrics is huge. And it actually can cost millions of dollars to those companies. So if I'm putting a collector in between and I'm just sampling and not sending all the data out, I can reduce the cost. Me as a company pay for observability by a significant amount. Another way a collector can be helpful is for supporting multiple things. You remember when at the beginning I talked about the cool thing about OpenTelemetry, the fact that I can easily switch between different platforms. So I can switch between Datadog to New Relic to Honeycomb whenever I want. One of the ways to actually enable that is by using a collector. You take a collector, you put it in your system, and the collector comes with this configuration YAML, And then by just changing one line in your configuration YAML, you can direct all the traffic to go to a different observability platform. So it's pretty cool, and it's a huge open source project also under the OpenTelemetry umbrella. And anyone and a lot of companies and huge companies are deploying these collectors to do this processing and supporting multiple things, like I mentioned. If anyone has any questions about OpenTelemetry, now is a great time to bring them up, or if anything that I said wasn't clear.
Usually
Cool.
there is a slight delay until people answer. So let's just now you asked it, and after in your next stop, let's answer some questions.
Okay. Oh, so you say I'll just continue and then we'll see if people ask questions in between?
Yeah, just continue now, and the next time we do a break, we'll see if there were questions.
Sounds good. Okay. So we've talked a lot about OpenTelemetry. I think now it's time to talk about OpenLLMetry. So I think the name says it all, but we can expand about it a bit. OpenLLMetry, it takes OpenTelemetry and extends it to support, generative AI and LLM-based applications. So I think the best way to visualize it is using this image. OpenTelemetry is what helps you take the data the way you're using, products like Chroma and OpenAI and Hugging Face and Pinecone and Anthropic and Gemini and many other different models that we'll see today, and understand how they work and get that information as standard observability with OpenTelemetry, which you can then connect to any platform that you want. You can connect to Datadog, Sentry, New Relic, Honeycomb, Dynatrace. There's like 20 plus more platforms that are supported with OpenTelemetry. So it's pretty cool. It's just taking, everything we talked about with OpenTelemetry and bringing it into the generative AI world. Let's begin by talking a bit about what's supported. So as I mentioned, OpenTelemetry supports 20 plus different instrumentations. We support OpenAI, Anthropic, Cohere, Gemini, AWS Bedrock, and many more. We support a lot of vector databases like Pinecone, Chroma, Milvus, and many others. And we also standardize and support many frameworks like LangChain, Llama Index, and Haystack. Let's take the Pinecone instrumentation as an example. Pinecone instrumentation takes your calls that you're making to Pinecone and provides you with a way to get insights and understanding into how your queries to Pinecone is working, what are the latencies, scores, and basically allows you to investigate, let's say you have a RAG pipeline that is using Pinecone, so you can actually investigate the traces using, that are actually making calls to Pinecone. And I'm going to see it in a bit. I think now is a good time to do a quick demo. I see one question. What is the core idea of OpenTelemetry? So OpenTelemetry is, and I think I'm going to say it in a bit, and I think will make things much clearer, is a way for you to get observability to generative AI applications with OpenTelemetry. And because it's using OpenTelemetry behind the scenes, you can connect it to any platform that you want. So you're free to use whatever platform you want to actually consume and see the data that we collect. And I think I'm going to show you everything now, and which will make everything much clearer. We're going to begin with a really simple example. I'm going to make my screen a bit larger so you can all see. Is it big enough?
I think if you can zoom it a little bit more, it would be better, but I can read what it says.
Okay, so this is a simple Bedrock application, and this is a good way to understand how Traceloop, how OpenTelemetry can actually help you. And let's see what's going on here. Okay, we have some, not a lot of lines of code that are calling Cohere on Bedrock. Bedrock, if you don't know, it's a service provided by Amazon within AWS, and it's sort of like a marketplace for a lot of models. So when you're using Bedrock, you can connect to a lot of different models. You can use Cohere, you can use Anthropic, you can use AI21. You can use many different models, and the API is the same. So if I want to switch, from Cohere to let's say Anthropic on Bedrock, I just switch the model ID, I change a couple of parameters, and that's it. It just works. And so what we have here is a really simple call to Cohere, to the LLM of Cohere. It's asking the LLM to tell me a joke about OpenTelemetry, and we're going to run it now, and we're going to see what will be the result. I'm going to make my terminal bigger as well. Let's run it. Simple. Oh, wait, I don't have it here. Great. Oh. Wait, I forgot to configure something. Okay. Okay, and we're back. So we're gonna run the Bedrock example. And let's see, we're gonna talk about OpenTelemetry in a bit, but let's just see, how the Bedrock example looks like. And it's super simple, as I said. Just calls Bedrock and then prints the response. And it's asking Cohere to tell me a joke about OpenTelemetry. Great. So how many OpenTelemetry developers does it take to change a light bulb? None. They'd rather write a new instrumenter. Okay. Now let's see why OpenTelemetry is helpful for us. So what I've done to enable OpenTelemetry is this line, only this line. This is one line which initializes an SDK, which we're gonna also talk about in a bit, and provides a single parameter, which is the application name. That's it. I've just done that, and what it enables me is to view this. This is a trace that shows me the execution of the application that I've just run. So I can see the Bedrock call here. Oh wait, something didn't work here well. But I can also see, I can see the output, I can see the response, I can see everything that happened behind the scenes. And more importantly, I can see it as a multi-step process. I can see that I had, a couple of different methods here that were being called, and I can see what happened behind the scenes. Let's take a bit more complex example, and we're going to talk a bit about tasks and workflow as part of that. Here I have a kind of a more complex application, which demonstrates a lot of things that are happening within OpenTelemetry. And I think it looks complex, but it's actually not really complex. And we're going to actually understand what's happening here by running the program and then looking at the trace that we get. So we're running it. This time we're using OpenAI behind the scenes. Okay, what happened here? Let's see. So this is a run. As you can see, many things happen here. We had 4 different calls to OpenAI, and it was a multi-step process. And as you can see, as before, we can actually see the call. We asked to tell a joke. We asked to then translate the joke to a pirate-like English, and then we got some history jokes, and we got some we added some signature to that joke. So it is like some nonsense multiple calls to OpenAI. Nevo, I think, can anyone see my screen? I think maybe it's a bit too small.
Yeah, your screen is visible, but it might be a little bit small for some people.
Okay, it is better now.
Yeah, I mean, actually, I don't have that much big of a screen, and I see it's small. I think it should be okay for everybody.
Okay. Okay. If anyone don't see this screen well, let me know. Someone is saying about the screen resolution. I don't know if I can change it. Okay. So this is a trace multi-step process. You can see we have like multiple calls to OpenAI, and it's pretty cool because I can see that the overall application took 5 seconds, and I had like multiple calls to OpenAI, and each call I can actually see the prompt and see the completions and see how many tokens did it take me, and there's like a lot of different details that I can see here. And let's understand how we got to this place. So this is the application, and as you can see, each step was a method. So it's a Python application. I started with calling this joke workflow, which is this method, and then this method called another method called create joke, and then called translate joke to private, and then called generate signature. And we can also see all of these methods here. This is pirate joke generator, this is joke creation, this is joke translation, and this is signature generation. So all of these methods from the application actually appeared here, and you can actually see the hierarchy. We can see that this method was called first, and it, as part of its execution, it called this and this and this. How did it know that all of this happened? So it's pretty simple. All I've done was just adding this workflow call that to this method, and then this task annotation and this tool annotation to these methods, to tell OpenTelemetry that, okay, this is something, this is a method that I want to actually see in the trace that I'm collecting. So any method for which I'm adding this decorator, tells the OpenTelemetry SDK, I want to track down the execution of this method. So then if this method is calling some other method, I can actually see each of these methods separately. So as you can see, this and this and this, all of these methods were being, singled out, and you can actually see them separately. In the OpenTelemetry, if someone is curious, in the OpenTelemetry universe, each of these rows is called a span. All of this is called a trace, and each row is called a span. And so you can say that by adding this decorator, we are enabling the OpenTelemetry SDK to collect a span for the execution of that method. And if that wasn't clear, because it might be a bit complex, feel free to ask me questions now. In the meantime, I'm going to talk a bit more about what we have here. So as before, I added this initialization line, which basically, bootstrapped everything and made sure that we collect all the spans and traces that we have here. And, except for importing the SDK, I also imported all the decorators that I've then used here. And the last thing that I want to mention here is that I've also added this interesting line, which is called set association properties. And this is a line that allows us to tell the SDK that we want to annotate the trace with some custom data. Let's say this trace was being initiated because it's a part of a chat that a user with a user ID 123445 initiated. So this is a way for me to tell the SDK, hey, listen, that this trace belongs to this user. And why is it interesting? Because then if you go here, you can actually see this user ID pops up here. We can also see the chat ID pops up here, which is also something we've collected here. So by defining this, I'm basically telling the SDK for the current trace, all of these properties are also what tells me, gives me an extra context about this trace. And this can basically be any arbitrary dictionary of any keys and values that you want. You don't have to use user ID, you don't have to use search ID, you can use whatever you want here. And the last thing that I want to tell you and you should mention is that the OpenAI span, this line, so as opposed to the joke creation, so if you remember, I actually put here this task annotation, where is joke creation task annotation? It's here. Here it is. I actually added this decorator so I can see this joke creation task here. But I didn't do anything to make this OpenAI appear here, right? It just appeared. So this is the cool part about OpenTelemetry. For any call you're making to an LLM like OpenAI, you don't need to do anything. We just understand automatically that you're making a call to OpenAI, and without you needing to do any change in your code, except for, of course, for this initialization, we log the call to OpenAI along with the prompt, the completion, token usage, and everything, the model name, and everything that you'd expect from this span. Next up, we're going to see another example, which is the using OpenAI with the vision models. And I think this is one of the coolest features we just added recently. And it allows us to see how even when if you send images to OpenAI, we can observe those images and understand what's going on behind the scene. Let's run the vision application. So the vision application is pretty easy. There's a couple of there's an image here of an elephant. I'm uploading it, sending it to GPT-4o Mini, and then I'm asking it to tell me what's in the image, and I expect to tell me that there's an elephant in the image. And this is how it looks like. Let's see if it ran. Great. Got here the response. I haven't formatted it well, so it looks. I just print the Python object, so excuse me, but you can see that the response I've gotten from OpenAI. The image features an elephant in a grassy landscape. The elephant is standing and appearing to be moving with its ear flared out. In the background, there are some zebras. Cool. But wouldn't it be nicer if I actually was able to see the image that I sent? Because it's really hard for me to understand if this description is even accurate or not. So let's go to trace loop. And this is the image. And this is the call to OpenAI. And yep, there's an elephant here. There's like some small zebras here. And this is the description that we've gotten. So it's pretty cool. I can actually debug and see what was the request, what was the response, how much did it cost me, and all right out of Traceloop or whatever platform you want. As I said, it can also connect to Datadog and many other observability platforms. And it's all just because I've added this line. I just added traceloop.init, which is initializing the OpenTelemetry SDK, and that's it. I get vision observability. I think Nevo asked me, does it support any LLM? So yeah, we support. Let's go to the documentation to talk a bit about what is being supported by OpenTelemetry, and as you can see, we have a lot of different foundation models that are supported, a lot of different vector databases that are supported. We support both Python, TypeScript, and we are now rolling out support for Go and Ruby. So someone asked here about contributions, and I'm going to expand on this in a bit. We're looking for, there's like tons of opportunities for contributions in Python, TypeScript, Ruby, and Go. So if you're looking to do something, feel free to join our Slack or help onto our open source, and you can find tons of issues there and things you can contribute. And yeah, so this is what we support today when we are constantly adding more and more models that are supported. You can also find in our documentation different integrations. So we support many different, platforms. There's like a huge variety of platforms you can connect to, and then you can see the traces that I've just shown you in your favorite platform. So let's say you're a huge fan of Signals. It's a nice open source LLM, open source observability platform that supports OpenTelemetry. You just set these two environment variables, and that's it. You can see traces in Signals. Pretty cool. Grok is one thing I really want to support. If anyone wants to help us with Grok support on OpenTelemetry, would love it. We're looking for contributions for that. Yeah, Grok is something we are not supporting yet. If we're talking about support, how to contribute and how to support the ecosystem, I'm going to show you the repo just so that people can understand how this looks like and how this works. I think it can be really helpful for those of you who are looking to contribute. So this is the open source. It's called OpenTelemetry, and similar to that, we have OpenTelemetry JS, OpenTelemetry Ruby, OpenTelemetry Go for the different languages, but they are all structured pretty much similarly. There are packages. Oh, we have Grok support. Sorry, this is super new, but we have Grok support. We just haven't updated the docs yet, but we have Grok support. We have other frameworks we're not supporting yet. So if anyone wants to look at the issues later, you'll see there the different LLMs that we're not supporting yet, but we want to support if you're looking to contribute. So each LLM has its own package. So you have OpenTelemetry Instrumentation Grok and Google Generative AI and Cohere and OpenAI, etc., etc. So each package is, it's separate. So, just opening up a new package to support a new model is pretty easy. You just go to any of these, you copy it, and you adapt it to support your favorite LLM platform. And on top of all of these, we have two kind of meta packages. One of them is the sample app. So if you go to the sample app, you'll find lots of examples here. And these are the examples I've just shown you. So if you run any of these examples, you can see how any of our instrumentations is working. And the last thing we also have here is what we call the trace loop SDK, which is what I used also to run the sample apps that I've shown you, which is kind of like a wrapper around all of that you see here. So the way to use OpenTelemetry is either by using the trace loop SDK directly. So you just install the SDK and that's it, it just works. Or you can manually pick and choose any of these instrumentations. So you can say, I just need OpenAI. Okay, let's take OpenAI. I just need Olama, just take Olama, and you can manually use them in your application. By the way, yes, we have a lot of examples, but we're also looking for more examples. So if you have something that you think is not shown here as a sample app, feel free to contribute. We are looking for more examples, especially around the framework. So if you have examples using LangChain or Llama Index, always looking for people who can contribute sample applications. Thank you. I mentioned Slack. If you go to the documentation, this is the link to the Slack. It's just traceloop.com/Slack. So feel free to join and ask me questions, and we're happy to answer you with first thing you can contribute to, how you can help us, how you can get started with it, how we can use it for your own use cases. We are always happy to help. Lastly, I want to show you an example with LangChain. I know it's a pretty popular framework, so we also have a nice example with LangChain here. Let's take this one. So yes, we always like to tell jokes about OpenTelemetry. So this is another joke about another way of telling jokes about OpenTelemetry. This time with LangChain. Yeah, unfortunately, we don't have Discord. We have a lot of enterprise customers, and they like Slack more than Discord. So this is LangChain. This is a LangChain example, and it's pretty similar to the previous ones. I just added this, traceloop.init to initialize the traceloop SDK, and that's it. One thing you'd notice here, which is important, is that I don't have any annotations. So if you remember, in each application that is not using any framework, I added these annotations at task, at agent, and then when I went to the platform, you could see this, workflow, this task, etc., etc. But here in LangChain, I don't need to add any annotations. And why is that? Because LangChain contains LangChain already explains to us, to the SDK, how the system is architected, how the different steps are built, so that you can automatically build those different steps, those spans that are compose the overall trace, and then you can just you don't need to do anything, and you'll get a nice trace. And we'll just see it. We'll see it in a second. Let's run it. So it's a LangChain application. Great, we got an answer. Let's see the trace. Let's give it a second. Here it is. And as you can see, there's a multi-step process here, even though I didn't put any annotation. We understand this LangChain, so we understand the different steps. So we get, okay, there's a runnable sequence here, there's a chat OpenAI, and we log the prompt, the completion, function calling, everything that you want. And all you had to do was just add this. That's it. Do I have a more complex example of LangChain here? Maybe. Let's see. I think I remember one. Let's see if I can find it. That's a good one. It's a LangChain agent. This will actually allow us to run, to create like a more complex application. So this is an agent. It has one tool which allows it to search with DuckDuckGo, and then I'm asking it, what is the full name of the artist who recently released an album called The Storm Before the Calm, and are they in the foobar database? If so, what albums of theirs are in the foobar database? This is just a random question. This is a random sample I found in the LangChain application. Let's run it as well, just as the last example. Here it is. Oh, wait. Great, so this is actually a multi-step agent call, so we're going to have a nice trace out of it. As you can see, a lot of things are happening here, right? Because we're making tool calls and a lot of like outputs. It's kind of hard for me to understand, what happened here. But if we go to the trace, then okay, now it's a bit clearer because I can actually see all the parts of the execution. There are many things that happen here behind the scene. I can see the call to OpenAI, and I can see the call to DuckDuckGo, and I can see there was like two calls. I didn't even know. It actually searched. It actually searched this twice, and then there was another call to OpenAI. So a lot of interesting things here happening behind the scenes, and I only was able to understand them when I built this trace. So it's pretty cool. Yep, that's it. That's it for me. If you have any questions, if you're looking to get in touch to understand better how you can contribute, feel free to reach out to us. We have tracer.com/docs is our documentation. You can also get to our repository here. I mentioned OpenTelemetry. There's also the OpenTelemetry.js, Go OpenTelemetry. The docs are also open source, so you can actually go, and if you want to fix our documentation, write more stuff about things that we're missing, feel free to contribute to our documentation, Ruby, and also there's like a nice demo I've built with Llama Index, which I haven't covered today. You can view. So many cool stuff, many things you can help us contribute, and yeah, and we are close to 3K stars, which is also pretty nice. That's it.
Thank you so much, Nir. Super insightful. Just to remind everybody that Traceloop also giving swag. So if you want to read everything about how to get prizes and stuff when you contribute to Traceloop, go to their main website and you will see a top bar. Just click on it and read all the information. So you can see everything there. Thank you so much, Nir, and we will move now to the giveaway. All right. I've already put all the results. Let me just give you again a small background. I'm going to spin the wheel. Then I'll ask you if you are here. If you are, then I'll just mark you. And by the end of the event, we are crossing the GitHub handles with the one that you registered to DevFest. And if it matches, you will see a special screen to claim your swag. If you submitted your name multiple times, especially if you've done it in a malicious way in order to win prizes, you will just be disqualified when I read your name. So let me share the wheel with you. Can even zoom it a bit. All right, let's spin it. Okay, Dark Developer 15. Nice. You have a handle that you can definitely identify over the chat. So Dark Developer 15, which is Sartak Tiagi. Are you here with us? I'll give you a minute because I know there is a slight delay. Okay, cool. Congratulations. So you will see it by the end of the event. So I'm just marking you here. Next one. Suryansh Rai. Let me check you. Yeah, only one time. Are you here with us? Suryansh Rai. All right, I'm moving to the next one. Okay. 20C02018. Shivang Pandey. Let me see that you put yourself twice. Yes. Are you here with us? Okay, congratulations. So I'm marking you. By the end of the competition, you will see this option to claim your swag. Thank you so much, everybody. And we are moving the event of the next Traceloop event to 2 days from now. So please be updated with the calendar. Thank you so much, everybody.